Question 5 says an electric dipole consists of 2 point charges plus and minus q separated by a distance 2d. Find the strength of the electric field at a point a distance x away from the centre of the dipole along the line of the two charges in the direction of the positive charges. You can assume x is larger than d. So we're trying to find the electric field strength, not between the two, but outside the region between the two. So we're going to be using our usual equation. F is Q1, sorry, it's just Q for electric field strength, over 4 pi epsilon naught r squared. R being the distance from the charge, but we've got two of these, so we need to add two together. So that's the electric field strength, isn't it? So E. So in this particular case, E, so if we do them one at a time, for the first charge is minus Q, and that is at a distance from this point of D plus X. And then the second charge is plus Q. And then the distance to that one is x minus d. So we could simplify this slightly by factorising out the q over 4 pi epsilon naught. So we've got 1 over x minus d squared minus 1 over, and then we'll just switch these two over so it's consistent, x plus d squared. So that's that first part. Expand your answer in powers, so there's a mark there, expand your answer in powers of d over x to show that when x is much smaller than d, the field drops off like 1 over x cubed. You may use the binomial series formula on the right. So we need to change the values in here to be in d over x. So we're going to divide through by x. Now the advantage of doing that is this then becomes 1 minus d over x inside the bracket here, which is going to allow us to use this formula. So if I rewrite what I've just done, then my first, so then well, let's write it first as so I'm going to take out the factor of x squared, so I'm going to put that there, and then my first term isn't, so sorry, I'm trying to do two steps at once. Let's write x minus d to the power of minus 2, but then I'm going to divide through here by x, which means I need to take out the factor of 1 over x squared here to make up for that. So that's what I'm doing effectively in one step here. So let's put my x squared is going to go here at the bottom, and then the first bracket should become x over x, which is just 1 minus d over x to the power of minus 2, and then the second one, for the same reasons, will become 1 plus d over x to the power of minus 2. So we've got these two terms in d over x, and we're now going to expand this using our binomial series formula. So the general form of this is that 1 plus x to the power of n is equal to 1 plus n times x plus n into a bracket of n minus 1 over 2 factorial x squared and then there's more terms after that. Now, because x is much bigger than d, we're going to say that really once we get to these x squared terms, they're unimportant. So in my expansion here, anything from this point onwards, I'm going to say is negligible in size. So all we're going to need to do is 1 plus nx in each case. So let's write that out. The electric field strength should be Q over 4 pi epsilon naught x squared, and then our first one, so the value of our, it's confusing isn't it, because I've got x's in both, but the value of our x here is d over x, and the value of n is -2. So I've got 1 plus -2 lots of minus d over x. So -2 being my n, d over x, or minus d over x being my x. And then there's some more terms here, but I'm going to leave them out because I think they're negligible. Minus, then I'm going to do the same, but for this bracket over here. So now my value of n is still -2. My value of x is now plus d over x. So this is 1 plus -2 times d over x. And then there are some other terms, but I think they're negligible. So from here, I can say that this is still Q over 4 pi epsilon naught x squared. And then if I put these together, I've got a 1 here, but minus a 1 here, so the ones go away. I've got plus 2 d over x here, and then I'm going to take away minus 2d over x, which gives me in total 4d over x in this part of the equation. So when I put these together, my 4's cancel out. On the top I get qd, and on the bottom I just get pi epsilon naught x cubed. This is what we wanted. If we just go back to the start of the question, show the field drops off like 1 over x cubed. Well, that's exactly what we've got here, i.e. E is proportional to 1 over x cubed.